play around with the function key. Go and see, LPE. Okay, this is to test live, neutral, live. This one is to test live and PE loop. Okay. Now we test live and neutral. Okay, we set the limit. Okay, just now I asked you to remember what is 1667. Here I show you. Now my circuit is RCD 30 milliamps. So I repeat again. So when you go to this, you go to limit, then set the loop limit. Enter. You can choose MCB if your circuit is MCB. If your circuit is RCD, then you choose RCD TT system. Okay. Enter. Then this one, the rating current of your RCD just now I show you is 30 milliamp. Okay. You must choose according to your RCD rating current. So if you choose 100 milliamp, cannot. Okay. Must choose 30 milliamp. Enter. Then safety touch voltage 25 and 50 volt. We choose 50 volt for general. Enter. Then RA factor. If this RA factor is 1. If this, okay, I factor you can choose any one, but leave it 1 because I factor is to time this result. This is the RA value. Just now I show you what's RA value. You all still remember, right? Still remember, this RA value must be lower than 1667, means your loop impedance is safe design. Okay. If over than 167 means your loop impedance cannot use. Your design must be redesigned. Okay. Okay. Now escape key. Now we test. We don't know how to connect. Go enter key. Press down. So this one live and neutral. This one I cannot show you here because play around with the live and neutral. Use this test probe. This test probe is the test probe EU plug. Some is UK plug, some is EU plug. Okay, So this is the test probe. Okay. So I connect red to red, green to behind here, live to live, earth to PE. Understand? Then blue to neutral. Then we put it back. So this one connect to here. Then okay, just now I mentioned to you the insulation test, continuity test, earth test. We don't need live wire. We don't need power supply. But loop testing, we need power supply. So we turn on power supply. Turn on power supply. You see the power supply on. I go and turn on my circuit here, my power plug here. Then you see power supply is coming in already. Then I switch on my RCD. Okay, turn RCD on. Okay, backward. I go and test LN. So L and N, it will come up prospective short circuit. What is this prospective short circuit? Prospective means you expect something to happen in future. Okay, when there is short circuit happens, this value, later the test value. Okay, now I run the test first. So now you can see here. Here is a red mark here. Red mark is you cannot run the test because your test probe connect wrongly. So off the switch, then okay, like that, turn on. So you see the green LPE and green LN means here got power supply. So here this mark not red, so okay to test. Okay, now you switch on. You You press the test, then you see the result. So you see this 0.69 ohms, it is lower than 1667, meaning to say this circuit design is okay, the impedance is okay. You see, it's all okay mark. Here is the operating voltage frequency. Prospective short circuit is when there is a short circuit happen, this is the maximum current can flow through that circuit. This is called prospective short circuit. It happened in future. Now haven't short circuit yet. If happen in future, the short circuit live and neutral go and touch each other, short circuit happen. So this is the maximum current can flow through this impedance. Okay, understand? Now we go and test the LPE. You see this, this table. LPE 0.00 high resolutions. High resolution test, 25 M output. This is 25 M output. But your RCD is just 30 milliamp, rated 30 milliamp. So what will happen if you supply this 25 M out? Your RCD will trip, correct? Okay, I show you. If you not believe me, later I'll show you. Okay, now this one we choose the test lead. If we choose this test lead, we need to use this test lead. If we choose this test lead, we need to use this test lead because every test lead, the resistance value is different. Okay, understand? So we choose this test lead because this test lead I cannot show you here. This one you want to claim live and neutral, it's very dangerous here. So I can show you this prop only. Okay, LPE test now is LPE of fault test. Okay, limit set as the limit, your RCD limit. Okay, as same as just now. Okay, now we run the test. See what happened to RCD because you supply this condition. This test is supply 25 amps. Okay, so what will happen? Your RCD trip. Okay, here so no result. So we cannot continue to measure the loop impedance. If using the high current, RCD will trip. So Q very smart. Q go and invest. Q go and come out with this anti-trip technology. Okay, anti-trip technology. So this is the button to show anti-trip technology function. Can test the LPE without trip. Okay. Now we switch to loop ATT. See what's here? LPE 2-wire. 2-wire meaning L live and earth. LPE 3-wire is live. It involves live, neutral, and earth. You see? So now we choose 2-wire. Choose 2-wire. Okay. How to test? Choose 2-wire. We test LPE. Just now we set to loop high current go out. RCD will trip. But Q very smart. It kind of loop anti-trip technology. RCD won't trip one. Okay. Then we set it's 2-wire test first. Later I'll show you. What is this pulse on? This pulse on meaning of this pulse on is before you run the loop test. Okay, listen carefully. Pulse on. What is pulse on? Before you start to run this test, there is a short time of high current out to the circuit. Okay, it removes the oxidized coating of the circuit to give you a more accurate result. So if you enable the pulse on, so it will give you a more accurate result. Pulse off, so your oxidized coating will not remove. So it also gives you a result, but still a result, but not so accurate. It's okay, can accept also. I think these two, the result is almost the same. Okay. Okay, now we set it pulse on to get a more accurate result. Okay. Now we set our limit, loop limit, also the same. We're using RCD. So all these set to the same RCD 30 milliamp 500 volt 1. Okay, I limit. Okay, listen. So I set one backward. Okay, now I run the test. Okay, run the test. Okay, cannot run the test because I never switch on my RCD. Sorry. Now I switch on my RCD. Okay, I run the test. You see, it will take some time because the current output is 15 milliamp only. So it can test the RCD from 30 milliamp up to 100 milliamp. So it will take some time to this 15 milliamp to supply to the circuit under test. So now this anti-trip result, it can test the loop impedance without RCD trip. So Q is very smart. So this one is this loop impedance value of the LPE, loop impedance value. So this is prospective fault current. Prospective fault current is when your live wire accidentally connect to the earth wire. It may happen electric shock. This is called PFC, fault current. Okay, maximum of 22 fault current can flow through this circuit when the fault current happen in future. Okay, understand? So we change to 3-wire test. Okay, just now 2-wire is used only live and PE. Okay, now 3-wire test is used 3 of this. Okay, understand? Now we run the test. We turn on our RCD. Okay, run the test. Then it will show you. Here will show you LPE. Prospective fault current is live and PE touch together, give the fault. Live and neutral is this one. This is impedance value. Okay, live neutral impedance value. This short circuit, when live and neutral touch each other, make a short circuit. This is a short circuit value. Okay, so this impedance is below 1667. So meaning to say your design of the impedance is safety to use pass. Okay, this engineer is okay. Okay. So, and then I want to show you, but I don't have MCB here. Okay. You see, go to limit. You try to change this to MCB. For example, MCBC, just now the example. Enter. You see the value 1.44 JS limit. Just now I mentioned the JS value must be respected. That formula must remember. Okay, RCD is RA, MCB is JS. Okay, understand? You see? Sorry. Now we change to another function, RCD function. Okay, RCD function to test the tripping current and the tripping time. Okay, you go and play around with this one. Auto. One time, okay, for example, now you set your RCD. This is your RCD rating current. Okay, this is our RCD type. Okay, you see, RCD AC. Okay, you see here, RCD AC general, RCD AC selective, RCD A general, RCD A selective, general selective, general selective. What is this selective and what is the general? General is without tripping time delay. With selective type is with tripping time delay. Some circuit design, they need this tripping time delay. I don't know why. You'll go and check out why they need this tripping time delay. But in our case, we don't. Our RCD is AC type and general type. Okay, we set it to this type. Then this is the phase, 0 phase, 180 phase. Okay, understand? So our current is 30 milliamp. Just now I show you already. 30 milliamp. And then this one is what? One time 30 milliamp. This one is the output current from the instrument to test the RCD tripping time. To test whether how fast it trips. This one is the 5 times 30. So meaning to say 150 milliamp output. This one is the, okay, that is 0.5 times 30 milliamp. So 0.5 times 30 milliamp is 15 milliamp output. Okay, understand? Huh? Okay, what is this function? This is RAM test. This is called RAM test. RAM test, you got see anything here? Tripping current. Here MA is a tripping current. RAM test is to test the tripping current of your RCD. Okay. Auto test. Auto test is to show you all the test result. 0 phase, 180 phase for half time, 1 time, and 5 time. Understand? Huh? So now I show you the tripping current first for you to understand our tripping current of the RCD. Okay. Now our tripping current, okay, this is RAM test to test the, you see the MA here, to test the tripping current. Tripping current, huh? Okay, now how to test? You don't know how to test, right? Press help key. Okay, this one I cannot show you, huh? This one is very dangerous. We go to this, we use this test prop. Same as the test prop show you here. Okay, now we turn on our RCD. Step one backward. We want to see what is the tripping current. Our rating current is 30 milliamp, but our tripping current must be lower than this. Okay, press. Trip at 18 milliamp. So meaning to say, your this 30 milliamp rated current RCD, your tripping current is 18 milliamp. Whenever there is 90 milliamp, RCD will trip. Below this 18 milliamp, RCD won't trip. Okay. Yeah, understand, huh? Now I show you, this one is half. Half can trip or not? Half of the 30 milliamp is 50 milliamp. Just now your tripping current is 80 milliamp. So this function, if I use this function, the RCD can trip or not? Cannot. This one time 30 milliamp can trip or not? Can, because 30 milliamp is over than 80 milliamp. Okay. This one 5 times more tripping. Okay, 150 milliamp output. Your tripping current is 18 milliamp. So can trip or not? Can. So I test. Huh? Auto test. Show you all the result. What I say, 0.5 milliamp output won't trip. 1 amp can trip. 5 times can trip. Okay. So you turn on your RCD. Okay. Press to start button. Then you see the result. Okay, one trip over than 2000 milliseconds. Okay, one trip. So now trip ready. Ask you to switch on your, because trip ready ma, your RCD off, switch on again, continue to test. Okay, it will trip. Then trip again, on again. Trip again, on again. So here it show you all the result of the 0 phase and 180 phase. 0.5 times 30 of the 30 milliamp, 50 milliamp can trip or not? Cannot trip. So it's so 2000 milliseconds. So it's longer time. So one trip. This one take 7.3 millisecond. Very fast. This one very fast. So your RCD is okay. This value must follow the standard. Follow the standard. Just now, TN system and TT system, still remember, below 200 milliseconds for TN system, TT system. For TN system, below 400 milliseconds. So this one is under the 200 and 400 milliseconds. So your RCD is okay. Okay? Okay, huh? So we go to another function. Okay. This function is called vote. You all know what is vote, huh? Singapore, Malaysia, vote is 230 or 240. This one you need to go and Google search what is the voltage of your country. Okay, every country there, the voltage is different. For example, Japan, I don't know, I think it's 220. This one I can't remember. I know Singapore is 230. Okay, so now you turn on. So you saw 230 volt. Live PE is 230 volt. LN, live neutral, 230 volt. Okay. NPE, Normally is 0. Normally is below 2 volt. You all understand this one? Live, neutral, and earth, you all must understand. Okay. So this is the operating frequency. Okay, now this is to show the voltage of each line. Live to PE, potential difference, live to N, potential difference is this, N to PE, potential difference is this. Okay. Okay, now this one is okay. Phase rotation. Phase rotation, we don't have 3-phase system here. Sorry, I cannot show you. So he also mentioned no 3-phase system. So you cannot see. Okay. So as I mentioned to you just now in my PowerPoint slide, when green 1, 2, 3, your phase sequence is correct. When red 2, 3, 2, 1, your sequence is another way around already. So okay. Then we go to earth. You see, you see what happened to my instrument. We go to earth. Now live wire is on. The live wire is on. I go to the earth. It will show what? Live. So as I mentioned, earth test, continuity test, insulation test, we no need power supply. If you put power supply, you see what will happen. It will show you live. Got live wire. Got live wire. Got live wire. Okay, understand? Okay, and before I go to earth, I got something to show you. Just now the touchpad. You all still remember what is touchpad? Earth wire wrong connect to live wire. For example, this wire wrong connect. Okay, wrong connect. Okay, so you go and touch. You see what happened? PEHIV. Earth has high voltage. Earth here has 100 over voltage. So it show you the circuit under test is wrong. Maybe the live and neutral wire is wrong connected, or this one you must let your engineer know. The live and the earth voltage is another way around already. Ask them to change back. Okay. Now you will change back. Now we go to earth. Earth, we cannot power supply. Turn off power supply. Okay, switch off. Switch off. Now we cannot. Now we connect we go to earth. Earth got 3-wire testing. 3-wire testing and 2-wire testing. You don't know what is 2-wire testing, 3-wire testing, go and read this book. I don't know you all have this guide to earth ground guide or not. This one you all go and read. You all more understand what is earth testing. Okay. 3-wire. You see, you press enter. Top key. So this is 3-wire method. 3-wire method. There is electrode. This is electrode under test here. Just now I show you the equal potential. There's electrode. Electrode is very important. It's a main ground of your building. Okay. This main ground must be designed properly because this main ground is your main earth. Okay. So this is the auxiliary spike. Auxiliary spike. This is called auxiliary spike. Okay. When you test the earth, you need this auxiliary spike. Okay. 3-wire method. Your wire must be 5 to 10 meter apart. 5 to 10 meter apart. Okay. 5 to 10 meter apart in this sequence. Must follow this sequence. S is at center. H is at here. If this H is at here, this S is at here, cannot run the test. Test the result is not accurate. So now we demo for you. Okay, this one red wire, you connect to red. Green connect to green. Yellow connect to yellow. Okay, see properly. Okay, can see? Can see, I don't know you all can see or not. Okay. Here red wire, earth wire, and then SP. Okay. SP is a potential. Then AC is current, current supply to test the earth. Okay. Now you see this. Follow the sequence. Just now I mentioned to you, must follow the sequence. Green first, then yellow, red. Red cannot be here. Okay, yellow also cannot be here. So green, yellow, red. Same sequence. So we connect like that. So this, assume this is 5 meters apart. Okay, assume this one is my building, my construction site. I want to test the earth. Okay. Now is one step back. We want to measure the resistance. 3-wire method. Then how we measure? Press start button. Then this is your resistance value, 9.62 ohm. This one acceptable or not? It depend on the site. There is a requirement. You must ask them for this resistance value, whether under which range is acceptable or not. Okay, so this is your earth resistance value. Understand? Okay, now I show you how to. Okay, for the two-wire testing. You press enter. This is two-wire testing. Two-wire testing, when your auxiliary spike cannot drive into the ground, you use two-wire method. But I cannot show you here. Okay, never mind. We go to 3-wire testing. Okay, we run test again. I show you how to record data now. This memory function. Okay, now we go to this memory function. Okay, for example, you want to save this. Press memory. Okay, so your earth 3-wire method, 9.63 ohms. You want to save inside this instrument. What is the circuit under test? 99. Board 99. This one you can set. Press enter. You go and choose whatever number you want. So up to 0 up to 99. So 100 data can save. 100 circuit can save. And it's the same for board. Also 100 data can save. Site 100. Okay, understand? So for example, we test this circuit. We put it as 99 number, board 99, site 99. We enter, we go, okay, sorry. Enter. Okay, we go to this one. Okay, we see the data. This data is whatever function here. One result called one data. Okay, one result called one data. If you test continuity, come out one result called one data. So how many data you can save? Enter. Okay, up. Okay, down. 900 data. 0 count 1. 0 to 999. So meaning to say 1000 data you can save in this instrument. Understand? So now I save it at 99999 all. This I save. How to save? Enter. Then here is save key. Enter. So it's safe. Then I go to, for example, how I look back my data. Press memory, press 2 seconds. So this is the data you saved just now. Press enter. You see, just now you save data, your save data. Press escape. You go and measure another. I test for you.那个 block， test block， 那个红色这。So now I save 2 data, then I show you how to transfer to PC. More data, you know how to play around. Okay. Sorry. So this one, go back. Okay. Now continuity test, you no need power supply. Same as just now. You go to escape key. You shift to continuity test. You save another result. Okay. Okay. Connect like this. Connect like this. like this. Just now continuity test. Okay, you press. So what's the result? 0.461. You want to save this data. Okay, memory again. So you change to 98 lah. Okay, now you change to 98. Okay, enter, go down, 98, enter, go down, 98, side, enter. So this one you change to any numbers, any numbers you like. Better, don't know got total or not. Okay, never mind. Enter. Okay, sorry. Enter. Okay, this one. Okay, so save. So now you got two data saved. How you see back your data here? Memory, press 2 seconds. So just now you got continuity test and the earth test result. You just save the continuity test, press enter, and see the result. See, this is data. Okay. Escape key. Now I show you how to transfer to the PC. So if you want to transfer to the KEW report, you need to use this one. What is this? What? 8212 USB. So here there's a connector here. Just connect. Understand? So this is USB. Okay. Just connect to your laptop. Make sure you already install